Our project is on how to make hydropower a more sustainable practice.
So some pros of hydropower is it's a renewable resource, so it has low greenhouse gas emissions, and it's also a cost-effective way of bringing a lot of energy to a mass amount of people. Some cons of hydropower is it leads to biodiversity loss. It releases methane by trapping organic waste. It displaces indigenous populations, and it causes floods.
One negative aspect is that the presence of dams means that fish like salmon can't swim upstream to reproduce. This damages the salmon population as well as the ecosystem as a whole because we know that food webs are very interconnected. So damaging the salmon population would also mean damaging the environment. And therefore, the government came up with the solution called the salmon cannon, which is basically a tubing system that guides salmon upstream over dams, which allows them to reproduce. And this reduces the ecological footprint of hydropower. Um, and when we look at this hydropower, there's several issues like these. One include hydro peaking, which is increasing river flow through the dams during peak demands of energy. And this is damaging to the river ecosystem because it changes the structure of the river, the water levels, and a solution could be to turn off hydro peaking during certain days. But there's a lot of issues like this that are come with hydropower, which leads us to ask the question if there are any better alternatives. And we believe that computational sustainability could be used in solutions to these alternatives, which we will go into next.
So this case study in the Pacific Northwest River Basin takes a multi-objective approach to investigate the balance between the economic costs and the ecological benefits of removing hydropower dams. The study had two main objective functions, which were to maximize river flow and to minimize the power loss. So the results of the study showed that it is possible to remove 12 out of 150 of the network river dams and increase river flow by 52% while sacrificing only 1.6% of hydropower in storage. So this really shows that there is a disconnect between infrastructural planning in the region, and there needs to be a more collaborative and centralized effort. More recent studies like this one at Cornell explores the future planning of dams while minimizing greenhouse gas emissions in the Amazon River Basin. The study encourages a collaborative and holistic approach to dam planning, which we have seen is essential to making hydropower a cleaner energy source.
So in conclusion, some things to think about are methods to protect the environment by removing methane buildup or trapping it to prevent its release into the atmosphere. Also coming up with an optimal solution for distributing energy to communities from these dams. In addition, trying to create a centralized committee of dam buildings and dam removals in order to prevent contradictory efforts of dams.
And these are our sources. And that's it. Thank you.